We are on the way to the Huon and Tasman Fracture Marine Parks, south of Tasmania. We're here to study deep-sea coral communities living on an unusually large group of underwater mountains known as seamounts. Here on Investigator, biological samples are collected so we can better understand the animals that call this reef home. Many of the animals that live in the deeper areas of marine parks are unknown to scientists or can't be identified from underwater video footage. To better understand what species live where, physical samples are collected using the beam troll, a small sampling net that is towed along the sea floor. When the troll comes in, it's action stations. The biologists wait eagerly for this moment, excited by the prospect of something no one has ever seen before. This is Investigator's Wet Lab, where biologists sort, label and preserve animals collected from the Huon and Tasman Fracture Marine Parks. Candice Untied from CSIRO is in charge of the 2 p.m. to 2 a.m. shift on board the vessel. She runs the lab when a beam troll is conducted in these hours.
So you've seen us bring up a beam troll. It's this really mixed bag of animals of all different kinds. And then we spend quite a long time sorting them into things that look alike. And we identify them as far as possible. We separate them out, we preserve them, and we give them a unique number so we can trace that data back. And then specialists take those animals and identify them even further.
Many of the specimens we collect on the voyage will end up here. This beautiful coral in front of me was collected from a seamount in the Huon Marine Park. It's now held in the TMAG collection to be used for further research. These animals live in cold, dark environments, clinging to the rocky sides of seamounts far beneath the ship. Coral communities are the heroes of this mysterious world because they provide caves, tunnels and scaffolding for other animals to hide in and live on. Kiralee Moore of the Tasmanian Museum and Art Gallery has spent a lot of time getting to know them.
The octocorals are part of the larger diverse ecosystem that we know exists in these cold water habitats. And some of them stand quite tall, some of them grow over things, some of them are soft, some hard. So it provides a huge variety of different substrates, different textures, different abilities for things to grow with and in or on. To see the specimens while they're fresh is a completely different experience to when they have been preserved.
Alexandra Weber is well acquainted with a common resident of these deep sea reefs, the brittle star.
There are more than 2,000 species of brittle star. Brittle stars are characterized by a round disc, so that's the center of the body, and it has also usually five arms. And here in the middle you can see that there's the mouth, so that's where they feed. This one is quite interesting because it is always found in association with a deep sea coral. So you can find it here. That's how we found it from the beam troll. So it was really closely attached to the coral. And at night, it extends its arm in the water column, and it feeds on the particles that are in the water. And it can also feed on the particles that are deposited on the corals, and like that, it also helps the coral to be clean of particles.
Karen Gallett-Holmes from CSIRO joined her first research voyage more than 40 years ago, giving her a unique and invaluable perspective.
Because this is an ongoing series of expeditions that date back to 1997. So we are still using photographs that date back to that date. So what we're looking for is things we haven't seen before or that are better than what we've seen before to try and record the colours. We're still learning a lot about these, and in the sort of sampling methods that we use, we are not in a situation of being able to pluck individual things up or spot them in situ. So this is the best way that we can to actually record it.
Identifying individual animals is an exciting and complex process. Sedentary or slow-moving animals are easily collected and sampled, but for faster movers, such as eels or fish, we need a different strategy.